Okay, so we're here at the horizontal curves chart, and I want to point two things out. Is that these tangent lines fully define this curve right here. They kind of lock the curve into place, and they also help define the intersection angle. Why are they called tangent lines? Well, because they run tangent to the BC and EC, which stands for the beginning of the curve and the end of the curve. We define our curves from the BC and the EC because they clearly define where our tangent line goes. So from the BC and the EC, we draw two tangent lines, and then we create an intersection angle. Notice that all of the factors such as tangent length, middle ordinate, L, length of the curve, or R, radius, can all be defined in terms of the intersection angle. This is because the length that we're evaluating is from BC to EC. If we wanted to measure a different part of the curve, we would need a different angle called the deflection angle. So let's look at this example now, and it shows a deflection angle alpha. And as we notice, this point in the middle, the midpoint, we have this line going through it, and the angle that creates, that is called the deflection angle alpha. Unlike the intersection angle theta that we saw earlier, alpha is actually figured on any point along this curve. It could be from anywhere from BC to EC, but if we take MP as the midpoint and we move to the left of that towards the BC, alpha will get smaller. And if we start from MP and go to the right towards EC, alpha will get bigger. So what is the equation that ties this all together? Well, it's simple. Alpha equals the station at any point A along this curve times theta, the intersection angle that does not change, divided by 2L, where L is the entire length of the curve from BC to EC. In this figure, point A is labeled as POC, or point on curve. Veterans Boulevard, Highway 101 on-ramp in San Francisco, as shown, is being designed to have a radius of 335 feet and a tangent distance of 545 feet. What would be the deflection angle theta and middle ordinate of the horizontal curve? Interesting to note, this is an actual on-ramp from images that I got from Google, and I went ahead and did the measuring tool in Google, and as we can see here, we have a tangent length of 545 feet, and we also have a radius length of 335 feet. So how do we go about finding the deflection angle? The problem says, what would be the deflection angle theta and middle ordinate m of the horizontal curve? It's always good practice to read the last sentence, because then you're going to know exactly what the question is asking for. And also we can see the four answers. The first one is in degrees and the second one is in feet. So basically we're looking for the deflection angle and the middle ordinate. So if we go back and look at our equation list, we have all the necessary equations that we need to solve this problem. And basically what we're going to do is use these equations in the following order. It goes T equals R tan theta over 2, one for the chord length and one for the middle ordinate. For the sake of this problem set, I'm going to solve it by hand for the first one, but after that I just plan to use the equations that I've programmed into the TI-84. But I just want to show you guys how I save a bunch of time by not writing out the equations. Okay, so writing out the equations might be 3 times longer, but I'm going to go over it anyways, and it looks something like this. We are given the tangent length and we are given the radius length. So what we do, plug into the equation, T equals R tan theta over 2. We solve for theta and we get 116.84 degrees. Next we solve for the chord length using the equation 2t times cosine theta over 2. We know theta, we know tangent, and after plugging into the calculator we get chord length equals 570.82. And finally, solving for the middle ordinate, we use the equation c over 2 times cosine theta over 2. Theta is in degrees. We know theta. We know c. Solving for m, we get 159.57 feet. So if we go back to our notes, we can clearly see that A is the answer because we got 116 for the intersection angle and the middle ordinate of 160 feet. So this chart is really interesting to me, and I've included in your guys' handouts. It's the section about horizontal curves that I've programmed into the TI-84. And as you can see, equation horizontal CRV number 4 has just what we need because we're given RT and we're trying to find either theta, L, or M. You guys are lucky because I've already done all the programming for you guys, so all you got to do is download the files and load it onto your TI-84. If you haven't done that already, please see the section where I show you guys how to do that. Horizontal curve 4, and if we're given the radius or the tangent length, we can basically find all three of these, theta, L, or M, but typically the equation might only ask for one, like theta, L, or M. Radius is 335 feet, and we also know the tangent distance is 545 feet. So we're just going to come to this program button right here, and we're going to go down to horizontal curve number 4. We're going to hit enter, run the program. Radius 335. See 335. Hit enter. Tangent 545. Hit enter. And there we go. When we have it, we have theta, M, middle ordinate, and L, arc length. Who doesn't like free content? Please like and subscribe. Tell me how I could do better. Leave a comment wishing which topics you would like to be covered next. I hope you have a great day. Thank you for watching. Pass Civil PE.